Hi, so now that we're at the end of 2025, I just wanted to record a quick video to summarize the work that we've been doing this year at Imperial College. So first up is Instant Policy, presented at ICLR 2025. Instant Policy is an in-context learning method which enables robots to learn tasks instantly. So here you can see two uncut videos where we're first providing a single demonstration of a task, and then the robot performs the task instantly with a closed-loop policy, whilst reacting to novel poses of the objects. So Instant Policy is based on a graph neural network architecture, predicting actions using graph diffusion, and it's trained only on pseudo demonstrations generated in simulation. Next up, R+X, Retrieval and Execution, which was presented at ICRA this year. So rather than physically moving a robot as in Instant Policy, another way to teach a robot is by observing humans performing tasks themselves. In this method, given a language command, we use a vision language model to retrieve the most relevant human demonstrations, and then we use an existing method of ours called key point action tokens to learn this task using in-context learning. And here we show a number of different tasks that our robot was able to perform when only provided with videos of humans performing similar tasks. Also presented at ICRA 2025 this year, we presented one-shot dual-arm imitation learning. This was our first work to explore efficient imitation learning for a dual-arm setup. And here we see a range of tasks that our robot was able to learn from just a single demonstration of each task. The method is based on visual surveying, using both a fixed external camera and a moving camera mounted on a wrist. We use 3 stages of visual surveying in a coarse-to-fine manner to enable the robot to reach and then interact with the object. This year, we were also finally able to announce one of the most ambitious projects we've worked on, Learning 1,000 Tasks in a Day, which was published in Science Robotics and was featured on the front cover of the journal. So in this work, we were able to actually teach a robot 1,000 distinct tasks within less than 24 hours of data collection. And the method is based on trajectory decomposition, so decomposing a trajectory into an alignment policy and an interaction policy. And we actually recorded a video showing us in the lab collecting the full set of demonstrations, which you can see in the video on the right here. At NeurIPS this year, we presented neural stochastic flows. So this is a method which solves stochastic differential equations and enables single-step prediction over arbitrary time intervals. In this figure, we show how our method achieves strong long-horizon predictions using this single-step transition, whilst the baseline methods require sequential solver-based integration. We've also recently been exploring the use of 3D generative models in imitation learning. So here we studied an idea where a robot would imagine a 3D model of an object after just a single demonstration of interacting with the object, and then we'd use this to augment a policy with training data with infinite demonstrations and simulated demonstrations using this 3D generated model. And in these videos, we can see our robot performing several different tasks, even though for each task, the robot was only shown a single demonstration approaching the object from a very different initial state from what we are seeing here at test time. And finally, we've also recently been studying active vision in imitation learning. So this is our recent work, Observer Actor. In this setup, one arm has a wrist camera for policy observations, and the other arm interacts with the objects using those observations. The active vision involves building up a Gaussian splatting representation which can then be explored virtually for active vision. And in these videos, we show how the observer arm and the actor arm work collaboratively to solve the task. And that's my brief summary of the main projects from our lab here in 2025. Thanks for watching. I hope you've had a great 2025 yourselves, and I'll see you next year.